giving me the opportunity to share with you today this talk. I've been very much inspired by all these very interesting and insightful talks that have preceded, and I'm going to try to be meeting expectations in terms of the topic that I will touch on today. So, my point today is relates to plants and plant science and the importance of agriculture really to help develop better nutrition for the world, in particular through products. And so I will start with giving a sort of global overview of the food context today. So I will first give you a quick reminder of the demographic situation. So it is predicted that by 2030, the world population will be 8 billion people, then about 9 billion maybe in 2050. The world population is going to become increasingly, or it has started to become increasingly urban. It is aging, especially in Asia, and it's also growing wealthier. So in 1965, the middle class represented about 20% of the world population. In 2030, it may be as high as 60%. As the population is evolving, the living habits are evolving, the diets are changing. So if you compare diets from about 50 years ago, they were relying a lot less on staples. So we are now eating a lot more staples. And of course, there has been a big consumption in meat, a big increase in consumption of meat. And this consumption is happening primarily in developing countries. So the evolution of our diets and, let's say, the context in which people in various parts of the world live are leading to different issues in nutrition. So malnutrition stems not only from a lack of food, but also from an excess of food. So while nutritional deficiencies are still rampant, there's about 1 billion people who are lacking the adequate intake of protein. 2 billion people are lacking essential micronutrients. Overnutrition is going on in parallel, and it is going on in parallel with wealth as well. Today, about 1.6 billion people suffer from chronic disease associated with nutrient excess. So in 2015, 193 countries agreed to work on these global development goals. And among those, eradicating poverty, eradicating hunger, improving health and well-being are the first three of these goals. The goal is to improve or eradicate these plagues by 2030. So these issues are, however, extremely complex, as you would imagine, and they will require really a holistic view across the value chain. So simply put, we will need to produce more food on the same amount of land and with less environmental impact. And this will all start with agriculture. So on the demand side, more food is needed that is nutritionally better in order to provide the needs for a growing population. On the supply side, there are several challenges. The first one is to improve the productivity of world agriculture in order to deliver the incremental volumes that are needed on limited land. This will be made difficult by a number of factors. Climate change and crop disease, which will impair productivity. The degradation of the environment, and in particular soils, which, unless addressed, will permanently hamper production. the loss of crop biodiversity, which limits the ability to deliver balanced nutrition to the world. And finally, and very importantly, the precarity of farmers, and that precarity of farmers needs to be addressed. Farmers need to have the tools to improve their income, or they will leave farming altogether. And we need farmers. So the first challenge is one of productivity. To deliver against the needs will indeed be very challenging. Demand is expected to grow by at least 60% by 2050. Until now, productivity gains have allowed supply to meet demand, but will this continue? A 1.3% yearly increase in yield for the top 4 crops, wheat, rice, maize, and soy, is estimated to be necessary, plus an expansion of about 135 million hectares. This is based on modeling. Both are stretched targets. While maize yields have been growing at a faster pace, wheat have not, for example. This is exemplified on this slide. So agriculture will need to produce more with less, produce for food and non-food needs, and do all of this in an increasingly challenging environment. Another challenge is climate change. In particular, rising temperatures, drought, and changing rain patterns will strongly affect agricultural production. A large proportion of arable land will become unsuitable. According to estimation, maize and rice yields could be affected by up to 10% along with other vital crops. Tropical crops may take the strongest hit. This is not related to nutrition, but quite important though. Coffee production, for example, could drop by up to 50% in Brazil, which is the #1 coffee producer. And climate change has also been shown to have a detrimental effect on the uptake of essential nutrients by crops. In turn, this can exacerbate nutritional deficiencies in affected areas. This was recently modeled in a study published by Myers et al. In 2015, as is illustrated on this slide. Once again, the most vulnerable will be at increased risk, as you can see by looking at Africa. So another problem is crop disease. Crop disease is and will continue to be a major limitation to productivity. Diseases are today a leading cause of food loss, especially in developing countries, where they are responsible for up to 40% of the losses of food in the food chain. Crop diseases can also affect food safety. The proliferation of certain types of fungal pathogens can lead to mycotoxin accumulation, especially in grains and fruit. This is shown on the right. It is estimated that about 25% of crops are affected annually. Mycotoxins are a major cause of morbidity in Africa, causing impaired development in children and liver disease. Soil degradation is also a major concern. It is affecting places that are in most cases those that have most benefited from the Green Revolution. Unless addressed, soil degradation will permanently impair productivity and aggravate issues that are linked to climate change. For example, by limiting water retention in the soil. Soil health is today one of the major concerns for the future of agriculture. So there is another challenge, and that other challenge is the decreasing diversity of crops. Although more than 5,000 crops are estimated to have been used in the history to feed the world, 75% of the world's food is provided by only 12 crops today. Out of these, only 3, rice, maize, and wheat, are the source of over 50% of calories coming from plants. If agriculture is to become the source of the diverse diet that is necessary for a balanced nutrition, many more nutritionally dense crops will need to be developed. And they will need to be developed to a level where they will become competitive for farmers to grow them as compared to crops such as wheat, corn, rice, and soy. Otherwise, they will not stand a chance on the marketplace. Finally, and very importantly, farmers are in much need of support, in particular smallholder farmers. These farmers are the most vulnerable, the least equipped, and generally the most forgotten. However, the smallholder constitutes an essential lever of development in developing countries. He or she is the key, especially in Africa, to alleviate poverty. It is estimated that a gain of 10% in productivity can translate in 7% decrease in poverty in Africa. So the empowerment of farmers, in particular smallholders, is essential. Without the right tools and support, they won't be able to run a successful and sustainable business and may have to leave farming altogether. Farmer empowerment is a key to success at scale in much of the developing world. So fortunately, science and the innovative solutions that come out of science will help farmers meet these challenges. One important area is plant breeding, which continues to rely on conventional methods, but leverages more and more cutting-edge science. Another one is plant science, dedicated to improving the nutritional value of crops. Today, this activity does not benefit from the level of R&D investment that can make nutritionally dense crops competitive. A third enabler will be agro-ecological approaches, which will allow gains in productivity based on a deep understanding of environmental interactions. These will be essential to address the issue of soil health in particular. Finally, empowering farmers with technologies and know-how that will increase their competitiveness and profitability will be essential for agriculture to deliver against the demand. So plant breeding has evolved to become a more and more complex and integrated approach to improving crops. Modern breeding methods now rely increasingly on genome knowledge. On the one hand, the knowledge that the genome delivers is applied to identify markers that are associated with crop characteristics of value. On the other hand, genome knowledge can be applied to targeting specific genes. Today, gene targeting methods are more precise than ever and can, like genome editing by CRISPR-Cas9, and we have heard a lot about that. This technique can be, of course, applied to plants as well. This technique can lead to results that are virtually undistinguishable from natural variation. So breeding has allowed impressive progress, as illustrated on the right, for maize, rice, and wheat. Modern breeding techniques will be crucial to improve the nutritional content of crops as well, large or small crops. For this, scientists will require the full support of society and a clear and fair regulatory framework. I've talked a lot about production, productivity, and the challenge facing agriculture to deliver the volumes. As I mentioned earlier, a large part of the world population is also in need of better nutrition. I mentioned how staples have become an increasing part of the diet. They have actually pushed out non-staples, such as pulses, fruit and vegetable. So can agriculture deliver better nutrition? The issue is certainly challenging. Why? Because the farmers want value. Nutrition does not always mean value for the farmer. Let's take the example of plant protein. Protein crops have decreased dramatically in Europe over the past decades. And the main reason for this is value and yield. A recent European study highlighted the challenge in order to generate the value that the corn crop would generate. Pea, for example, will have to yield more than twice the yield that it has today, and lupin would have to yield 5 times more. This is a problem. Does that mean that nutrition cannot become part of the agenda? Well, we hope not. Applying modern crop science to more staples and nutritionally dense crops will be essential to help them succeed on the marketplace. However, the level of investment in some of these crops has been largely insufficient. So as you can see on the left, it was reported in Nature Plants recently. It is striking to see that the crop of the importance of cassava, for example, has received less attention than crops like cucumber or tobacco. And this is measured as the number of publications that have been associated with those crops. One important approach will be to enrich these crops in essential nutrients. The biofortification approach, implemented, for example, by Harvest Plus, and which Nestlé is hoping to leverage in its products, is likely to strongly contribute to improving the nutritional status of populations in the future. So recently, traditional varieties and species, land races, have been rediscovered for their nutritional potential. In the case of wheat, ancient species have interesting health benefits and could be used to improve commercial varieties. Much effort is now put in exploring natural diversity in common plant varieties, in traditional varieties, or even in related species, to cultivated species. The hope is that tapping into these new sources will not only improve crop performance, for example, decrease disease susceptibility or increase drought tolerance, but it will also increase the nutritional value of these crops. So I want to go back to biofortification for a minute. Plant science has started tackling nutrition heads-on, in particular, the issue of micronutrient deficiencies. So a large initiative called Harvest Plus is building on the capacity of expertise centers around the world and is starting to deliver very promising results. Looking at the big four deficiencies in a range of staple and non-staple foods, it is concentrating on how genetics can help deliver more micronutrients into crops. This is called biofortification. A striking example is the development of maize that is enriched in beta-carotene, also known as provitamin A. You have to know that vitamin A deficiency is a major issue, leading to blindness in up to 500,000 children every year. A cross-continent collaboration is delivering the first variety with high levels of beta-carotene in countries like Zambia, Ghana, and Nigeria. Most importantly, the biofortified corn yields significantly more than current local varieties. This is very important for farmer adoption. This is a fantastic result, but the major challenge is to scale up the solutions. One of the obstacles is cultural. Maize, in the mind of farmers in Africa, has to be white or yellow, but not orange. Another is the supply of seed and the take-up by the value chain. This issue will need to be tackled to ensure the widest impact of these great achievements in plant science. In order to address major ecological concerns such as soil degradation, new approaches in farming have to be implemented. They have to be based on a strong scientific understanding of the crop in its ecological context. There is hope that so-called agroecological approaches will be key to restoring soil health, for example. This slide illustrates how different farming methods can affect soil texture and chemistry, and also the biological life in it. An experiment conducted at Rothamsted Research in the UK showed that no-till farming, which consists in leaving crop residues in the ground after harvest, has a strong positive effect over time on soil porosity, as well as carbon and nitrogen content compared to conventional or even organic approaches. In short, in no-till farming, under the conditions of the experiment, the soil improves over time. This type of knowledge will be essential to help guide farmers to use the right techniques in order to restore the healthy soil structure and composition that they need for long-term sustainability. We all know that productivity is a function of genetics, the environment, and agronomic practices. So you can relate to what we heard earlier on humans. Well, it's the same thing for plants. So it will take a complete package to deliver against the needs. It is estimated that genetics will have to carry much of the weight, maybe 50% of the impact has to come from genetics. However, the gap between potential and actual yields will only be bridged if the right agronomic practices are put in place. And so agriculture is going to have to become smarter, with better genetics, more precise, climate smart. We'll have to pollute less, contaminate crops less with pesticides, and we'll have to attend to its soil. So farmers will need to be empowered. We need a combination of innovative tools and approaches to be profitable and sustainable on the long term. All these will need to be provided to farmers and be put to use. Among key recent developments, some show much promise. For example, digital technologies, which are adopted even in Africa. They will help the farmers be more informed in real time, which will help them increase their efficiency and reduce their risk. Automation will become more and more important for farmers to remain competitive. In fact, one of the major issues farmers are facing today is this increasing scarcity of labor in rural areas. Not a surprise, since people are moving to the cities. In order for the farms to sustain productivity on the long term, farmers will need to turn more and more to environmentally friendly solutions. Among these, biological solutions are developing at a fast pace, for example, to control disease or to promote beneficial plant-microbe interactions in the soil. So now we have to deliver all of this to the consumer. So the consumer does have his say on what he or she wants to eat. While food safety and appeal are essential, the consumer is asking for more transparency and wants to know what is in the food, where it comes from, and how it was made. In the end, the consumer will look at a number of criteria, in particular whether it is a good value for money, whether it is healthy, natural, coming from the right origin, not wasting or damaging natural resources in the making, and respecting the rights of farmers and other stakeholders in the supply chain. So we are facing a very demanding consumer. So what does that mean for industry? From industry, agriculture is the beginning, but we have to look at it end to end, and agriculture has a lot to deliver. Raw materials need to guarantee that food products will delight consumers, is number one. They will need to be compliant with food safety requirements. In addition, they will need to be coming from at the right price, behave well in the factory and on the shelf, and if possible, be a source of interesting benefits for the consumer and differentiation for the food manufacturer. So this is a very long list of characteristics that the ingredients have to meet. But yet it is possible to reach consumers and to improve their nutrition through products. So I'm going to give you an example of this. And we believe that food companies are uniquely positioned to create a pool and impact nutrition throughout the value chain. As an example, the popularity of Maggi products gives Nestlé a solid platform to reach vulnerable populations, be widely and regularly consumed, which is important for nutrient deficiencies, by populations at risk, and help improve their health status. And how is this done? Well, this is done through fortification. Today, 103 billion servings of fortified foods are delivered through the Maggi brand yearly, and this is half of about 207 billion servings that are fortified through Nestlé products today in total. So fortification is going to be important. Yes, that's not going to happen. I'm not sure this. Okay, this doesn't work. Maybe I can use the. There's the next slide. There seems to be a problem here. Actually, there is an error in the slide. It's not 207 billion biofortified, it's 207 fortified portions. I don't seem to be able to move to the next slide. Can somebody help, please? Well, what I want to say, and hopefully we can fix the slide. So to widely consumed products such as Maggi cubes, so you have to know that in Africa, there is, especially in places like Côte d'Ivoire, the person who cooks in the house, usually the mother, will buy one Maggi cube and use one Maggi cube a day, split it in half, use one half at lunchtime and half at dinner time. So the industry can impact nutrition, but it can also have a wider impact through a sort of trickle-down effect and their influence on supply chains and on farmers. The demand for biofortified ingredients will help healthier crops get off the ground to ultimately reach the consumer through products. However, products that are naturally enriched with micronutrients will not solve nutrient deficiencies on their own. But they will help kickstart the process, giving the early adopting farmers a market and focusing attention on the performance of the varieties and the commercial benefits. So this is now moving to biofortification and getting natural products that are naturally enriched in micronutrients such as provitamin A to deliver their benefits not only through the products but also through the supply chains.
It doesn't work here.
No.
Si è inchiodato, devo riavviare. Lasci un secondo. Levami anche dal bip, magari, grazie.
Okay, thank you. So it's working, so great. So this is what I was illustrating, and this is what we're trying to do with provitamin E corn in Nigeria in particular. So now moving on to protein. So there is more and more interest in plant protein for products in the food industry, and there is one reason is the impact of protein from animal sources on the environment. So the above chart illustrates feed-to-food conversions for different animal protein sources. At the pace that animal protein consumption increases, there won't be enough water and land resources to produce enough animal feed. In addition, the livestock sector is estimated to contribute almost 1/6 of greenhouse gas emissions related to human activity, with 41% coming from beef alone. Besides, the water requirement per kilogram of beef is 15,000 liters of water. It is estimated that each person will contribute 400 kilos of CO2 equivalent per year on average by consuming animal products in 2050. In contrast, an individual who changes to a Mediterranean diet that is more relying on plant protein would reduce the contribution of CO2 emissions by 25%. So plant proteins are very important in developing a sustainable nutrition scheme for the future. Well, however, moving to plant protein is going to be a long-term effort. It will be a journey that will first start with the acceleration of using available protein ingredients. Tomorrow, we will need to have optimized plant protein crop production and also improved product functionality using the new ingredients. Because at Nestlé, for example, we use a lot of dairy protein. Other companies use a lot of meat-derived proteins, but they don't necessarily have the same functionality as plant protein. So that will need to be addressed. So finally, and in the longer future, we will need to not only strengthen the plant protein sector, but rely on alternative protein sources and technologies as well. So maybe insects will be part of our protein sources in the future, for example. So we are now we now want to focus on nutrition as a central scheme. However, this cannot happen at any cost. We want to deliver nutrition in a way that will not compromise the ability of future generations to meet their needs for a good diet, that is compatible with their culture and enables an active and healthy lifestyle. This is what sustainable nutrition will be about. So I will conclude now and give you some take-home messages. So first, agriculture needs strong science to build resilience and to deliver against future nutritional needs. So science is essential. More research investment will be necessary to improve the benefits of crops for nutrition and health, since the focus today has been on productivity. A systems approach is absolutely required to deliver a successful technological package to farmers. So it's not just genetics, not just agronomy, it's going to be a combination of a number of technologies. Stakeholders have to work together to overcome the challenge of scaling up agricultural innovation, especially in developing countries. So it's not, unfortunately, it's not just about science. A big challenge is still to deliver the benefits of science all the way to the farmers, especially smallholders. The food industry, which requires nutritious and plant ingredients, can be a catalyst in the development and adoption of nutrient food crops. So this is going to be, I think, a role that we can play. And finally, empowering farmers, especially the smallholders, to increase their income would be crucial for the future of agriculture and ultimately the future of food. So thank you very much.